Napakadaling hanapin yung area ng isang plane figure by using the formulas that you have learned in your geometry. However, yung mga formulas na yon, pwede lang natin siyang i-apply kapag ganito yung mga figures natin. Regular yung kanyang mga shape. Paano kapag ganito na yung hinahanap nating area? This one. We are looking for the area of the shaded region. So let S be the region that is bounded by the curve of f of x. The vertical lines x equals A and x equals B. Yung region S natin lies dito sa kanyang baba. Ngayon, ang challenge sa atin is to find the area of this irregular shaped region. At pansin natin na yung kanyang boundaries naman hindi straight. Okay? Straight dito, tsaka dito, pero yung sa taas, hindi. Archimedes actually solved a similar problem using the method of exhaustion. That is, dinivide niya itong region na ito into smaller shapes whose area can be exactly calculated and add the areas of the smaller shape to estimate the area of this region. So, ginawa niya, hinati-hati niya ito sa mga maliliit na areas na pwedeng kunin yung area and then pinagsama-sama niya yon para i-estimate yung area ng region na ito. So, paano niya yun ginawa? So, let's consider this region bounded by the curve f of x equals x squared, the vertical line x equals 1, and the x-axis. We can divide the bounded region into 4 vertical strips by drawing vertical lines at x equals 1/4, at x equals 1/2, at x equals 3/4. Tapos, ito. So, we have now 4 regions. So, hinati natin siya sa 4. So, in here, pwede tayo ngayong mag-drawing ng rectangles whose widths are the same as the base of the strip and whose length are the same as the right edge of the strip. So, ito yung unang rectangle natin. Tapos, yung base niya, yung length niya is yung length nitong right edge. So, ito yung second. And then, we have the third. And we have the fourth. The measure of the width is 1/4, okay, obviously, and the measure of the length corresponds to the value of the function at the right endpoint. So, for the first rectangle, our width is 1/4, our length is yung value ng function at this point, so that is, since our function is f of x equals x squared, so we have 1/4 squared, or that is 1/16. For our second rectangle, our width is 1/4 and our length is 1/2 squared, so that is 1/4. For our third rectangle, our width is 1/4 and our length is 3/4 squared, so that is 9/16. And finally, for our fourth rectangle, our width is 1/4 and our length is 1 squared, or 1. Now, if we get the sum of all the areas, okay, so 1/4 times 1/16, 1/4 times 1/4, 1/4 times 9/16, 1/4 times 1. The sum of the areas of these 4 approximating rectangles is 15/32, or that is 0.46875. And obviously, yung area na ito is greater than yung area nung talagang curve natin. Kasi nga, di ba, obviously, kita nyo naman, may mga sobra dito sa kanyang approximating rectangles. Now, what if, baliktarin naman natin, instead na yung right, yung left naman ang gagamitin natin. So, yung rectangles natin, ang widths niya are the same as the base of the strip, and the length are the same as the left edge naman of the strip. So, measure of the width is 1/4, and measure of the length corresponds to the value of the function at the left endpoint naman. So, first na rectangle natin, ito, tapos yung left. Second is ito, tapos yung left. Then, third is ito, tapos yung left. Then, fourth is ito, tapos yung left. So, yung length natin sa first rectangle natin is 0 squared, so that is 0. Yung sa second naman na rectangle natin is 1/4, so that is 1/16. Sa third na rectangle natin is 1/2, so that is 1/4. And doon sa ating last rectangle is 3/4 or 9/16. Again, if we get the sum of the areas of these four approximating rectangles, we get 7/32 or equals 0.21875. And obviously, this is less than the actual area kasi nga, pansinin nyo, may mga white spaces, so may mga kulang. Therefore, we have a bound now for the area. We know that the area is between 0.21875 to 0.46875. Now, what if pinalaki natin ng pinalaki yung number of rectangles? Anong nangyayari doon sa error? Pansinin ninyo, mas lumiliit yung error. Ganon din dito sa left, mas lumiliit yung error. Okay? And if we use 50 rectangles, tignan niyo yung ating bound. Lumiit na siya. So we have 0.3234 up to 0.3434. What if 100 rectangles ang ginamit ko? Di mas maliit na naman yung error. Pag 1,000, pag 1 million, okay? So, yun yung idea. Paramihin mo ng paramihin yung approximating mo na rectangles in such a way na paliit naman ng paliit yung error doon sa actual na rectangle. And kapag sufficiently many na yung number of rectangles mo, you are sure na yung area na hinahanap mo is matutumbok na niya. Okay? Close to the actual area na siya.